So just a reminder, a lot of you have already seen this already, but we're going to be having increased oxygen in our tilapia RAS system from the bells from 10:05 to 10:30. RAS construction at Freedom Fish Farm from 10:30 to 11. Marine shrimp culture and recirculating aquaculture systems from Dr. Andrew Ray from Kentucky State University from 11 to 11:30. That is a previously recorded webinar because it covers exactly what we wanted to talk about here today. But Dr. Ray is here for the Q&A. Just it's already recorded. No point in doing the same exact thing. And then we'll have some open discussion from 11:30 to 12. And if we spill over a little bit past 12, that's perfectly fine. First, do want to make sure that we acknowledge all of the farmers who are supporting us here today down at the bottom, as well. Of course, this is Virtual Saturdays with OAA. Kentucky State University, where Dr. Andrew Ray is located, and then, of course, NCRAC being a partial sponsor to this, this webinar today. We will talk about it, I believe, a little bit later on some more, but right now, I'm not speaking on behalf of the OAA, but there is a membership drive right now, which ends February 28th. And we'll be showing a little bit more on that a little bit later on. But thanks to them for their assistance with this as well. So with that, we got 2 minutes early on my little housekeeping. If you do have questions, sorry, I almost forgot. Let me stop share. If you do have questions, you can put it down in the very bottom. If you're not used to using Zoom, very bottom, there's a Q&A. You can put your questions in there, and we'll either answer them in the chat or we will answer them live. And then if need be, we can unmute a panelist to be able to allow, or I'm sorry, an attendee to be able to allow them to talk. But depending on what's going on, we may just have to utilize the Q&A. All right, with that, I'm going to go ahead and mute my screen or mute my audio and get rid of my screen so that the presenters can go ahead and start, which is the bells. Craig and Tracy, I will turn my video camera back on with about 3 or 4 minutes before your presentation is set to be up, so you know to go ahead and wrap it up.
Good morning. I'm Tracy Bell, and my husband Craig Bell is here with us. We own Ripple Rock Fish Farms in Frazeysburg, Ohio, and we've been in business since about 2013. So we're right at 8 years now. We've made lots of mistakes, and we keep moving forward and hopefully learn from those, and hopefully we can share a little bit with you as well so that you don't make the same mistakes. We feel like now here we are at year 8, and we may actually be getting on top of this a little bit. I don't want to say that and jinx it, but we are happily in the black. And so it's been a journey, and we recently, in the last 2 years, are researching a grant on oxygen. And so I will share our screen and talk a little bit about that. Mostly Craig will be sharing what he's engineered for that. But this is our farm, the further building here in Ohio. And we started this SARE grant in March of 2020. And the title of it is Improving Oxygen Transfer in a RAS System to Increase Production and Promote Sustainability, the Sustainability of Raising Tilapia Indoors. So the problem that we were having is, as we added fish to the system, our oxygen, we could never get the oxygen at the levels that we wanted. The oxygen readings would be low. And when I say low, you know, in the 2 range. And so we would have to stop feeding. And then the oxygen would go back up, and we would turn on our feeders again. And we just would hit oxygen limitations continually. So Craig, do you want to talk about that? The result of that, obviously, is that our growth rates were compromised because we were not able to feed consistently. and therefore your profitability suffers. So I kind of manage the numbers side of the business, and Craig is the engineer and the facility. So Craig, you want to talk about that?
So yeah, the bioreactor takes about 3/4 of the oxygen demand on the system. In the biofilter or bioreactor, we have the little media, I guess Caldus, I think is a name brand, but that is a oxygen hog, and to convert the process, the nitrification process that goes on there is all driven by oxygen. So that would be our limiting factor, and our ammonia would spike because our oxygen was low. And so, like Tracy said, we would back off the feed and everything comes back into line. So that was our problem. I don't know if you want to go to the next. We as we moved from just the simple blower is what we started with, and blowers using air stones and locations, and bubblers in the bioreactors to add not only oxygen but also turbulence to keep the media moving. We moved from a blower, we started getting liquid bottles, those bottles that are up top in that picture. They're costly to refill. We'd have to transport them. The oxygen guys would deliver them if we wanted them to, but that was an added cost. And so when we bought our first home health oxygen concentrator, a little gray machine there, it was on Craigslist. Is where I found a number of those. It's almost like we purchased Thor's hammer as far as providing oxygen to our system. The dewars, the oxygen bottles up top. When we started, we were going through about one of those a month, and it wasn't too big a deal. But when I went through one of those in about a 9 or 10 day stand, I knew we needed to do something else. And so we bought that little oxygen machine and actually got rid of then the bottles, the liquid bottles altogether. The problem though with those little machines, they don't put out a lot of pressure. And so you have to use air stones as the media to transfer oxygen, and they're not real efficient because the oxygen just bubbles to the surface, much of it, and is gone. And you can't use the ceramic diffusers that sort of fog the water. You can use those with higher pressure like the liquid bottles had. And so that was another dilemma. And as we, all of a sudden we had plenty of oxygen, what happened? And we started loading the systems with more fish. And then all of a sudden we're back to our age-old problem of, we don't have enough oxygen again, and the bioreactor is suffering, and the fish, we can't feed them enough. So that's where we wrote this grant, got a couple other farms involved, Curtis and CJ. Curtis with Freedom Fish Farms, and CJ is another one that's in with it. So maybe the next slide, Trace. So this was a first attempt. We would inject oxygen coming out of the biofilter, so it would go to the fish first, and right about at that point there, we'd have oxygen go in, and then basically the theory was to give it some contact time. That 2-inch pipe flows, it would go to 3-inch where those gray reducers are, and just leave it going down that W, if you will. We never did come up with a really good name for whatever that was, the W or the whatever, just a up and down, give it some time to transfer then a bubble, if you will, of oxygen to liquefy it. And as it would come out of that bioreactor, it kind of worked, and then it kind of didn't work, and it really, at the end of the day, we'd count it up as a fail. This didn't really significantly add oxygen to our system in any great the saturation levels didn't come up all that significantly. So check that off as a fail and tried something else. This one was a little bit of a copy out of the Pentair catalog. Again, you've got the home health oxygen concentrator that creates about 90+%, 92.4% oxygen, and getting it to transfer then into from that machine. We have a Venturi, and I don't know if Tracy, if you can point to the little black Venturi, we'll get another picture here in a minute, but right at this point, we would inject oxygen. The Venturi creates a little bit of a suction, so it actually pulls the oxygen into the pipe. So the little compressor, the home health concentrator, doesn't need to create a lot of pressure to overcome the pressure of the water in the pipe and overcome that to get it to inject. So it actually sucks the oxygen out of the machine a little bit, just a slight suction. That then, with that oxygen in that pipe, we take it up to about 8 feet, 9 feet high. And as water comes around, then there's bubbles that are going up as the water's going down, and it shears that oxygen bubble, if you will, just shears it down into molecules, and it just fully saturates it. It doesn't come out as a bubble when it hits where the fish are. So with this setup, we were able to significantly increase our oxygen saturation levels. Go to the next. So here's a little bit more of a close-up on the Venturi. You can move your cursor there. Yeah, that little black Venturi creates a little suction to pull the oxygen, and all these valves is when we were testing it, this picture was. And so we actually pulled water off of a pump and pump water then through the Venturi. The bottom valve in the middle, you actually open it some and open those two little red ones above that wide open, and that bigger valve at the bottom then needs to just create a little bit of a drag so that water's forced up through that Venturi, which creates the suction. And you can tell by the gauges on top how much. As we've built a number of these, I don't even put gauges on them anymore. You can just put your finger over the Venturi and feel when the suction is just right, and that's a good setting on that bottom valve. So then again, the oxygen is pulled into the pipe. That water then flows up, comes down as the pipe goes from 3-inch to 4-inch to 6-inch. And it gives it some retention time. So the water slows down in that oxygen saturator. And then as it enters the system, then there are no bubbles that just get vented. So what do we have? So that, go ahead, Trace.
I was just going to laugh that he takes the those gauges off, and now he's saying that you can just feel it. You can. It's kind of like the way my grandmother used to tell me how to cook. You know, you just put in enough, and then you just know. And that's the way. That's the way. That's the way Craig builds things. Is you can just feel when it's just about right. And so there you go. We can laugh a little at ourselves, right?
And so the screen shot on the right was this morning's oxygen. We have a monitoring system, YSI monitoring system, and that was our oxygen this morning as I walked in. The fish in Raceway 4, what we call RW4, are the smallest, so they have the least need, and yet they're getting bigger. I can tell because the feeders had gone off maybe an hour before this picture was taken, and so they're beginning to hit it a little harder. And so I continue to add a little more to this system, take away a little bit from this system. And anyway, that's current levels. We used to struggle. We'd be in the 2s, 3s, riding that line between 2.7, 3.5, and now we just don't have any issues with providing enough oxygen for the systems. Next picture. You can speak to that.
So this is just, hopefully will give you a little bit of an idea of where we were and where we are now. In 2018, so we sell pond fish and we sell food fish. And in 2000, as you can see the blue line across the bottom, the pond fish are pretty level. We sell about the same amount of those every year, and it's kind of just been something we've made room for in a few tanks so that we could sell some pond fish. But our food fish is really where the significant change has happened, because the pond fish we sell when they're smaller, they don't really ever spend much time in our raceways, and that was really the focus of this oxygen project. Where the food fish, we grow them out in the raceways, and that's where we were having issues with oxygen. And so the orange line represents the food fish. And as you can see, in 2018 and 2019 particularly, we were kind of bumping up against a ceiling of about 30,000 pounds of fish a year. And we really couldn't get past that. And then with this oxygen project that began in early 2020 and gradually was installed on each of our 4 raceways, the end result was our food fish, the pounds of food fish, went up to 37,000. We finally broke through that 30,000 pound ceiling for annual production. And in 2020, then we were up. That equates to about 28.5% increase in production in 2020. Based on the first 2 months of 2021, we are projected to be producing 45,000 pounds of food fish this year. If we are on track based on January and February. So that's an increase of about 50% in our production from years 2018 and 2019. So we feel real good about that and feel like this was really quite a breakthrough for our farm. Craig, can you speak to, so CJ of Stagecoach Fish Farm, CJ Johnson, is another farmer that was partnering with us on this project, and he installed his just this last week.
This past week, he sent me a picture earlier in the week, and he said, "Hey, I'm about ready to turn this on." I think it was Wednesday he turned it on, and so Thursday morning he called me and he said, "Craig, my oxygen levels have doubled." And so he's running currently, he was running 2 5-liter machines, 2 5-liter oxygen machines, and he had to turn one of those 5 liters. He goes, "I bet I can almost turn one of them off." But he was turning it down to like one's at 5 and one's at 1 liter a minute. So his oxygen levels significantly increased, so much over one night, he couldn't believe it. And as he continues to then play and dial in the how it affects his system and where he needs to put oxygen, he saw great success just turning it on this week. So somebody asked a question that flashed by: how many oxygen machines do we have running? We looked at trying to maybe go to, are these little machines really the way to go? Because I at one point had probably 15 or 16 machines, 15 machines running, I think. before this project, and we just could not get enough oxygen flowing. And so, you know, getting a big, like at a hospital, a big oxygen tank sitting outside, we're looking at that. And so, you know, how many of those machines are, you know, what's the number, you know, how many liters per minute, how many kilograms, of all those questions were being asked. And so we did a test. We picked up 2 of the liquid oxygen bottles, and I was going to let them run, see how long they'd run. You know, I got down to 10 days on one. And so I picked up 2 bottles and we were going to run, and I blew through 2 bottles in 2 days. So, and they're like 240, can't remember what that is. They're 240 Dewar bottle. And anyway, so 2 days blew through that, and just the amount of oxygen we're going through, it's significant. And so right now, as of today, we have 9 oxygen machines running. As the weather warms up, we'll kick on a few more, but with these oxygen saturators in place and a Venturi to pull them in, much better transfer of oxygen. And so we have turned oxygen machines off. So we're down from that number down to right about 9 machines running. They're, I like the 10-liter machines a little better than the 5-liter, but I've got, there's probably 1 or 2 of those machines that are 5-liter machines running, all in all. So
yeah, do you want to talk about this slide, or I can? Kind of the wrap up.
Yeah, they're pretty cost effective to install. There's some PVC, the Venturi, they're, you know, $100 or so, and you've got the fittings, so it's not a significant cost to install. It's PVC pipe, and the ability then to meter out oxygen and have it hit your systems, it's huge. And so we've been able to stick with a small home health oxygen generator, a little concentrator, and not have to go to the cost of a monthly tank rental, a big, you know, have people come and refill it, those kind of things, and get away from those bottles. And it's just you can find them on Craigslist. People that don't need them anymore, their grandkids sell them, and there's a story with everyone. But they're nice. They can be rebuilt fairly inexpensively. There's companies here in Ohio that do that, and so.
The bottom line is our production has increased, like I said, you know, almost 30% last year, while we were still in the mode of installing these, and we expect it to increase 50% overall this year. So that really just hits your bottom line, because our costs did not go up commensurately. The only thing that's gone up is feed, because we can have more fish and we can feed them what they need to be fed. And so our utilities bill, if anything, have gone down because we've turned off oxygen machines. And so that's kind of a summary of this research project. The 3 farms that have been working on this is our farm, Ripple Rock, and CJ's farm, Stagecoach Fish Farms, and then Curtis at Freedom Fish Farms. And so, and Curtis will be speaking next. So if he has anything to add on his progress on that, you'll hear from him next. So
I think we need to give a shout out to Laura too, that I saw flashed on, and years ago she was pretty supportive, and
yeah,
anyway, and look at us now. I told her as I left, when she first gave us a tour down at Piketon, I'm gonna go home and build a building. She goes, "Easy, Craig, easy." And so
she tried to keep our feet on the ground, and Matt Smith has followed that up with lots of practical education for us. And
Matt Smith actually
one-on-one.
saved our fish farm. I've told that to a lot of people that he said, I don't know recirc, but I know water quality. And he taught me some things about water quality and ammonia levels and toxic ammonia levels, which helped us then push these systems a little further. And it actually saved our farm. So shout out to both of them. Thanks for your help.
That's very kind, guys. And I also saw Laura say thanks so much and happy to see your success. So hopefully you'll see that down there as well. So I will remind everybody to please post your questions in the Q&A, not in the chat, because there's other discussions going on in the chat regarding helping to keep us on track and on time. So if you have questions, put it over there. And we do have 3 minutes left. So there were a couple questions put in the chat, Tracy and Craig. So I'll say those real quick. And if we do run out of time, I'll go ahead and have that switch over to Curtis. All right, so let's see. The first one I see going here was, so for example, for the 5 liters, you can say the 5 or the 10 home health oxygen concentrators. Someone to know about what you're seeing as far as the cost on Craigslist for one.
You know, you can usually get them for about 300. I've spent a little more. There's hours on them, but usually about that. I think you can find them for $350. And at times
Thanks.
People are getting rid of them that you can just, somebody doesn't know what they have and pick one up for $100. So just kind of keep watching.
Great. And so Tracy, you showed the slide right when this question was being asked regarding the pounds of fish per gallon of water. I think you were projecting around 47,000 or so, not including the pond fish, for poundage in 2021. For the crowd, you guys want to talk about how many gallons of water you guys, what your system looks like?
So we have 4 raceways and they are about 11,000 gallons, Craig, is that correct?
Yep. Yeah.
11,000 gallons. So there's 44,000. And then we've got 3 fingerling systems that are total about 10,000. So we're at about 55,000 gallons. Would you say, Craig? Would you agree with that? About 55,000 gallons. So, we're bumping up against, so it's not a pound per gallon because they're not all pound size fish at the same time, but we get fish in every 6 weeks. We get last night we got a shipment in from when picked them up at the airport, 5,500 baby fry every 6 weeks.
Okay, and thanks so much. There was also a question about how many oxygen concentrators that you have, which you already answered that. You got about 9 running, but about 15 or so on hand. Some 5, some 10. And it looks like I'm probably about there on chat. So, and we are at 10:29. So thank you very much, Craig and Tracy. For those of you who are on here, this is being recorded and we will get this on YouTube just as soon as we can. And this will, this is a great addition to talk about the outputs from their SARE grant that they have. And I did post we're in the North Central region if you are here in the Midwest. And so that's been posted. The link to that has been posted in the chat, as well as a link to you guys' YouTube channel, because I saw that down in the bottom. So thanks very much, Craig and Tracy. And you guys don't go anywhere. If you have more questions for them, there is an open panel Q&A at the end of this. Thank you, guys. All right, next up we have Curtis. All right, Curtis is going to talk to us about the construction and what's going on over at his Freedom Fish Farms. And Curtis is also has a tilapia system, and he's also located in Ohio, and he also went through aquaculture boot camp. So Curtis, I will turn my video back on when there is about 3 minutes before 11. So go ahead, thanks.
Sounds good. Thank you. Thank you guys for all joining. Like was just mentioned, My name is Curtis Graham, and I own and operate Freedom Fish Farms. We are just outside of Zanesville, Ohio. And there's a I just will go over basically the construction of putting this RAS system together and kind of how I got into it. This presentation is going to be just a lot of pictures. We took a lot of pictures and things that we kind of used as we were putting this system together. But the journey, where did it begin? This was back in about 2014, again with Laura 2, putting together the boot camp along with the OAA as support. But yes, I got to be a member of that boot camp. And the boot camp just basically helped future fish farmers and current fish farmers to just get a foot in the door, basically, and understanding what are we getting into, and is this something that we can do. And so the boot camp was a year-long program, and you basically went down there on the weekends. It was one weekend, one Saturday, usually out of the month, where you would go through presentations and a lot of hands-on exercises and things, and that was very valuable. And that encouraged me and introduced me to the OAA as well, since they were a part of that. Pilot systems started many different variations I had, but this is one of them in a basement where I was at the time. And so I think I had quite a few different aquariums there and set up through different moves. We put this system together. This is just a simple IBC tote system with a couple filter 55-gallon drums. And so this was just introducing me to, can I actually raise fish, and is this going to work for me? And can I understand the process of keeping these fish alive? And sometimes you're successful, and sometimes you're not. And so these fish, I would say if you have a bucket load of dead fish, you're still doing okay. If it's over a bucket load, you might, it does happen at times. But no, these fish in that little system, that IBC tote system, they did well. Basically what killed these ones is it just got really cold, and my heaters went out one night. And so, yeah, tilapia in Ohio, they don't like temperatures in the low 50s. So you definitely have to keep the water heated. But again, this was just a few fish I had, just kind of testing things out. Not that I wanted to kill them, I really wanted to try and eat them, but they ended up frozen that night. And so after going through boot camp, really deciding this is what I wanted to do, built some of those pilot systems during boot camp. It was time to start designing. And where I was at in life, I guess, with family, location, we knew that we weren't in our forever home yet. So I wasn't going to build this huge system until we found the place that we wanted to call home, basically. And so once we finally found that place, this is when the design started happening, location-wise. This building is that we ended up designing was 150 foot long by 52 feet wide, and they are 12-foot ceilings inside this building, basically just a pole barn building. The orange tanks here are the grow out tanks, and these are 20-foot diameter, basically swimming pools. And this was just designed in Excel. And so I just used Excel and just kind of, there's many different variations of this design. Here's filter equipment, but it was just making sure that all this stuff's going to fit in the area that I needed to fit. Here's my little fingerling system up front as well. But how did I come up with the design? The design happened through a lot of different farm visits, going and visiting other fish farmers. And this was really encouraged to us going through that boot camp, and encouraged through the OAA. And the OAA puts on a lot of different workshops. And the big thing that they did, except for COVID year last year, is they put on a really nice convention, basically, or a really nice weekend where they do a lot of workshops, and you can interact with the members and networking with all the members and getting introduced to the fish farmers that are actually doing this and have been around doing it for a long time. And so that was very helpful. And so I visited, I don't know, 5, 6 different actual indoor recirculating fish farms. And so this design kind of came to me through Tom McAmer and Jerry Wendell. Jerry Wendell was in operation. He kind of built a couple of different variations of his system. And so I figured, hey, if he built another variation of his system after he was already up and running for 10, 15 years, it must be something that's working for him. And so this kind of is what I took and went with. Also, when you are designing your system, make sure you have a good access. I had to put in quite a few driveways to get access to the building, but don't overlook that small step of making sure you have good access to your facility. Finally, construction began, groundbreaking. So again, we went through that boot camp in 2014. A lot of what I heard in that boot camp is slow down. Don't just jump into things, or else you can lose a lot of money and a lot of fish that way. And so I definitely took the slow steps to get there. So we started in February of 2018. There was lots of delays along this to get to this point. Financial aid, getting financial assistance for this, it's not easy, and so that was one big delay. That was about a year-long commitment just going to get financial aid to get a facility like this up and going. We finally ended up going through the USDA with Farm Service Agency. So here's just a couple pictures of the building actually getting built and constructed. I was lucky that the contractor that I used to help put this building together, he basically hired me to help him as well. And so that was very valuable for me to learn, but also just to be a part of it. And there's lots of choices and decisions you have to make during the construction, and just to be there and present, it was valuable for me. So finally we got at least the metal on the outside of the building. Again, putting the lights and everything on it inside. All this, you kind of have to, you really have to think through all this design, because once your tanks and everything's in place and you start filling this stuff up with fish, is not the time you want to be redoing things. But so you try and think ahead as much as you can. Insulation, we used spray foam insulation. And so I did spray most of this spray foam in here. And that helps. That's a good vapor barrier, and it's a very good insulation for your facility as well. We also sprayed the ceiling as well. And so that's kind of tricky, spraying the ceiling, because you can only put up so many panels at a time as you're trying to spray this to get it to adhere and have plenty of ventilation up in the ceiling. And again, your driveways, make sure you do have that good driveway base, because it's something you're going to be using every day, and you kind of overlook it, but you definitely need good access. You're going to have lots of equipment being delivered, fish coming in and out, and you need to have good access to your facility. Onto the fingerling system. So this fingerling system started basically as construction was still going on, with the building too being finalized. But the fingerling system is just a small system, IBC totes. I have a level controller. Here's our level controller, drum filter. You have a sump tank biofilter. So again, grow out tanks, A level controller, if you guys aren't familiar with the level controller, it's basically just controlling the level of the water in your grow out tanks. So the water flows out of these IBC totes from the bottom, comes across. They each have their own standpipe inside this level controller. That level controller then can control the water level. I can take that standpipe out and drop the water level in each one of these individual tanks if you need, especially when you're going through and taking fish out. It's a lot easier to drain them out to get the fish. The water goes through this 55-gallon drum, which is my level controller, into a small little drum filter. This drum filter basically has the water coming into it. If you don't know a lot about drum filters, all your water flows through a screen, a drum. As the screen starts getting plugged with effluent from the fish and fecal matter, the water in this tank here starts rising as that screen material starts getting plugged. Once you hit a certain level inside this little tank here, it activates a float switch, and that float switch then rotates the drum, which is that screen drum. You also have a spray nozzle on the top, spray bar here, that with high pressure, like a pressure washer would, it rinses off that drum filter and all that fecal matter that's on top. It hits basically a little gutter system inside here and then goes out the facility through this pipe here on the top. This is the back side of that. Basically, drum filter dumps into a little just sump tank. The pump is in that sump tank, pumps the water back up into the filter as well. And then this biofilter has its own level controller exterior here, standpipe, to keep that level inside the biofilter. Water basically comes off the bottom, up through that loop, and then back into the grow out tanks there for the fingerlings. This picture, if you're building a facility like this, you're going to spend a lot of time getting this facility built and up and running. But no, I really built this for my wife, but as a gift. But I did use it in the facility, I guess, from time to time. So first fish, they did arrive, fingerlings. I did get them in July of 2018. Is when we got the first batch of fingerlings in. And again, these are just small fish. They come from Aquaculture. Definitely work with Craig Bell there at Ripple Rock, Craig and Tracy, and we try and buy them together so we can do some cost savings, buying a lot more fish together, and we save a little bit on shipping as well. On to the grow out system. So we're going to be talking about the grow out system here, these tanks. Currently in my system today, I only have half this facility up and running and operating. So we only have 4 of these tanks that I initially installed for the grow out system. We started that installation December of 2018. This other half over here, I am currently building it right now, and I'm hoping to have it up and running. At least these first 2 tanks I'll have up and running probably at the end of the month, and then the next 2 maybe the month after. I just need more room to expand. I was kind of dragging my feet, not wanting to build this side until I knew that this side was up and running and operating the way I needed it to. Kind of learn from best practices and see what tweaks and modifications I needed to make to put this side up and going. So we're going to start with building the drain assembly and the drain lines because they're going to sit underneath the tanks, and so you got to put those in the ground first before you put the tanks on top of them. This drain assembly idea did come from Tom McAmer. This is kind of what he used in his facility that he has. But you do have to basically make the things and manufacture them yourselves. So you have a large drain, which is going to be the bottom drain. And this is an 8-inch bell here that reduces down to 4 inches here. and then the same on the other side is a smaller bell there as well. I think it reduces down to 3 inches, so it's a 4-inch. So this is my bottom drain that I use for the bottom, and this will be the top drain that I put a standpipe in to skim off the top. But these platforms will sit down in the ground. So you have to dig trench lines. I set those down in the ground, and then you run all your drain lines and pipes all individually over to what we'll get to is a level controller over here to control the level inside those tanks. And then backfilling, make sure you backfill. When I backfilled, recommendation again from Tom, and just kind of makes sense. We backfilled with sand. You don't want to put the same dirt in there because you're going to be putting a tank or a swimming pool basically on top of it, and you don't want that to settle. And if you ever have to dig up any of those drain lines, it's going to be a lot easier digging through the sand than here outside of Zanesville. We have a lot of clay, and so a lot of this is digging through clay. But drain lines, backfill, make sure you're using something that's going to settle in nicely. So we use sand. Here's some additional lines that I tee off of as well. These are just for drainage when I'm draining the pools and things of that nature. I can drain the lines off to waste. Over here, after you backfilled with sand, we did use a plate compactor to make sure we're going over top of that and it's compacted as tight as you can get it, because you do not want it to be sagging down afterwards or compacting after you got the pools on top of it. After the drain lines get installed, we move on to the level controllers, the drum filter, and the sump. And so this is another level controller built out of an IBC tote. Drum filter. This drum filter came from Pentair. Drum filters are not cheap by any means, but that's going to do a lot of work in your system all the time, and it needs to operate all the time. And so you need to kind of put your money into equipment, or invest into the equipment that you know is going to be basically the workhorse of your system. And then a sump tank that it's going to flow into. Again, the level controller, all the pipes from those 4 individual tanks, the 4 swimming pools, they will connect up to this drum or this level controller. And then you're going to have all the water coming out of the level controller through this outlet there. Kind of what it looks like after you get the pipes and stuff installed. And kind of what it's looking like in operation here with some standpipes coming up. So all these standpipes on the left-hand side there, they're all representing the bottom drains. So this would be tank 1. This is a bottom drain, and this is the top, which is the standpipe that's inside the swimming pool or the tank. That's just skimming off the top of the water. And so this would be tank 2, tank 3, and tank 4. And so I can remove these standpipes and lower the water in each one of those tanks if need be at different times. Onto the drum filter. So after we get through the level controller, all the water flows into the drum filters. You can kind of get a better idea of what that drum filter looks like. There's some of the screens that the water flows into, has to flow back out of those screens. All the effluent gets stuck to the inside. You do have some controls that you have to install with those that come with that. And then you hit your sump pump, or in the sump tank. This is where I have my pumps that I use right now. So after you kind of get all the tanks, all the level controller and your sump installed, you move on to making sure that you have your tanks and your pools installed. So again, using sand or some type of gravel to kind of level this off. It's real easy to level off. You can still see you got your drain in the center. I did lay down some styrofoam as well. Down, these are 20-foot diameter tanks that's going on top of this. That's just to kind of give you a little bit of insulation barrier from the ground, especially with tilapia. They do need to be a little bit warmer than ground temperature. And then these are just basically swimming pools that we're putting up here. Before COVID, these swimming pools were fairly easy to find and fairly inexpensive. Each one of these pools were, I think I found them for about $500, a little less than $500 a pool. So again, I saw some other fish farmers using these type of, this is just your basic swimming pool. And it seemed to work really well for them, especially since they're not outside, they're indoors, they're not getting all the UV light damage. There was farmers getting 5 to 8 years pretty easily common out of these swimming pools. And so for that cost, rather than using something that might be a little larger cost to get in, you could be talking 8,000, 10,000 for one tank if you're using other materials. And so there's two of the pools set up. This is connecting the swimming pools and putting the drain together. Now that the pools are installed, it is kind of a little nerve-wracking when you have to cut holes in the bottom of your brand new swimming pools, but that's what you have to do here. And so cutting holes, making sure you use a very good silicone to seal those off. And then I put a cap there on top. This is the bottom drain, again, using that'll go over the large hole there in the bottom. This is kind of what the facility looks like now, at least on the one half side, the other side still being built. And we'll talk a little bit about the biotanks. So the biotanks, they sit in between the two of the pools, and this is the water coming in. The water will come into the top of these biotanks, fills these tanks up, and we have biomedia that we'll put inside these. All the water the water will come off the bottom. So the water comes in, goes all through the biomedia, comes off the bottom through these chutes, and it'll go into the tanks. This is the biomedia that I'm using. It came from Water Management Technologies, which I think now is that Innova C, but this is fairly large biomedia. And it seemed to work really well. This is the water coming inside one of those tanks, and it cyclones this media around. So it's constantly moving and cycloning around inside that tank. This media is semi-buoyant, so it does it wants to float in the water column. And we'll move on to water pumps and oxygen. And so over here is this pump setup went through many different variations, adding pumps, as I'm learning about pumps. I'm still learning about pumps and how efficient they can be and just how they move water most efficiently. But this distribution line, right now I think it's at a 3-inch distribution line here. These are fairly inexpensive pumps. When I say inexpensive, they're right around, I don't know, maybe, I think they're $150 a pump, but they are not very efficient when it comes to cost of running them. And so These are 1 horsepower pumps, 1.5 actually, 1.5 horsepower, just sprinkler pumps. Yes, they move water, but they do cost a lot to run. So I am kind of right now going through and swapping out some pumps that cost a little bit more, but I'm going to definitely save in electric cost over time. Over here, this is kind of what the bells were talking about at Ripple Rock. But again, this was my setup that I used. Kind of as I was talking with Craig, going through Venturi's. I think this is almost before we even thought that there was a grant that was going to happen to kind of help us out here. But pump going through a Venturi, you can see the oxygen line plugged in there. I am using oxygen concentrators, just like Craig is, those oxygen machines. And then some contact time with the water, and it connects to the lines up top. Some different variations of that. Built my own. These are called a space cone, so just to give it more contact time. It works fairly well. My good friend Craig had this that he couldn't use at his facility just because it just didn't work very well. So I tried to install it at my facility and see if the difference of these two, if there was any difference. And truly, I haven't seen much of a difference from this expensive space cone to this homemade inexpensive space cone. The only difference and change here is adding this 6-inch line PVC pipe just to make it a little taller, to give it even more contact time. So extending these lines, making them a little taller in the future to help, but very efficient way of getting oxygen into your system. We added fish into the grow out system finally February of 2019. Lots of memories there. And then just real quick, we'll kind of get close to time, but coming up here is jack of all trades, master of none. But make sure if you're building stuff like this, you need to get your hands on it is the best way. If not, you better have a really good friend or close friend to help you out. But electrician, this is just a small piece of making sure you know how to do this stuff, or you're at least handy enough or have a really good friend to help you with this. HVAC, hooking up heaters, making your own wood burners to kind of help, especially on these cold days here in Ohio. Just general carpentry, just being, having the know-how, making a rope ladder. I had to get down in the bio tank from time to time. And so things like that, moving large pieces of stuff around in your facility. It's not easy to put some of this stuff together. And so just having the will and the know-how. Making nets, might have to take a sewing class maybe, but there's lots of good YouTube stuff out there. And hey, you might even have to do I think this is called a necropsy on fish. And so, hey, I went to a workshop here at the OAA, and they did a necropsy, and so it was really helpful learning how to do that. So I thank you guys for your time. If you do have questions, definitely put them in the Q&A, and you can always reach out to me if needed. But thank you very much. And this is kind of some of my helpers and future laborers, you could say. I guess they're already helping here. So thank you very much. We'll look for some questions here.
Great job, Curtis. We certainly appreciate you giving us an overview on that. And yeah, I love to see the picture down in the bottom left-hand side. That's all that feed right there, part of the Ohio Aquaculture Cooperative, probably. So we can chat about that during the panel Q&A. But there is a feed buying cooperative here in Ohio called the Ohio Aquaculture Cooperative. And you can also reach out to Curtis if you're interested in learning a little bit more about that, because he's secretary, or he's involved with them as well.
Yes. I do see some Q&A. You want me to go through these right now real quick?
Let's Yeah, there's only two and they're pretty quick. So if you can do those Q&As, that would be great because we just have a recorded presentation after this. Go ahead.
All right, so the size mesh that I'm using, I'm thinking you're asking maybe, yeah, in the drum builder. It is 8 micron, I guess, 80 micron, I believe, is the size of mesh that I'm using. And source of water, it is a well water. I'm lucky, very fortunate. I do have a deep well here. It goes 400, almost 500 foot in the ground, and so I have not ever ran out of water. It's what I use for my house, and I tap into it for the fish pond. If you see the bottom picture there, you got those 2 tanks. That's what I fill up with water. So the blue tanks in the background where the kids are unloading the feed, those are 40 or 4,000 gallon tanks. And so I let that come up to room temperature. And how do I control the temperature? Right now it is just through the air. So I'm just using an overhead heater to control the air temperature. I am in the process of putting in a boiler system right now so I can heat up the water instead of the air so much. So that's to come.
Thanks so much, Curtis. You can go ahead and stop share on your screen. All right. Thanks again for Curtis. He's going to stay around as well. So you guys think more about his presentation as well as the Bell's presentation and ask those at the Q&A section, the panel discussion at the end. So next up, I've got a 32.5-minute presentation from Dr. Andrew Ray. Again, it is previously recorded, so I'll just let it play. I will note that this was actually, it is going to be a little bit more scientific because, of course, we've got a researcher presenting, but it was actually originally for a university in Brazil. So there are just a couple metrics in there that I'll convert over to English units, but it does give you a bit of a history, but really pay attention towards the end because they start talking much more about the research that's going on down at Kentucky State University, which is Frankfurt, just a couple hours straight south of Columbus. They have a great aquaculture and aquaponic program down there as well. So you'll learn a little bit more from Dr. Ray. Again, this is marine shrimp production and indoor production systems.
Matt, did you share your sound when you shared this video?
Sorry, guys. Apparently, I don't know what I'm doing. Share sound. Okay, now we should be.
Thank you very much for having me. My presentation is about marine shrimp culture in recirculating systems, and I changed the name just slightly from biofloc to recirculating systems, and I'll explain a little bit why as I go through my presentation. What I want to do in this presentation is provide a slight introduction to shrimp farming, the way it's intensified over the years, and how that's led to the development of things like indoor systems, which are quite intensive in some cases. And most of these systems that are housed indoors are recirculating systems. I'll describe a little bit about that and the different types of recirculating systems that could be used, some of the filtration mechanisms, design, how that affects production, and then touch on a few of the current issues to help try to foster this technology and develop it further. So there's a lot of ways to grow shrimp, and what we're talking about is marine shrimp here. Little Penaeus vanameae. It's the most commonly farmed shrimp in the world now because it is adapted to high density and it's very disease resistant. It's been in captive breeding programs for quite a long time, and so through selective breeding we've been able to get a lot of really good genetics. The animal grows faster and faster all the time. And it's really winning out to be the most domesticated shrimp species in the world for farming. But there's different ways to grow the shrimp, and it depends a lot on your goals. It depends on your location. How much water can you use? If you're right on the coast, you have a lot of options potentially. If you're inland, like we are, Kentucky is a completely landlocked state. We're hundreds of kilometers away from the nearest seawater. And so that's something very important for people who want to grow shrimp in a region like this. I've gotten a lot of interest from people in Brazil too that want to try to move inland. Biosecurity issues are a huge concern for the shrimp farming industry. It's impacted the industry heavily over the years. The climate, this is a warm water species that we're talking about, needs to have at least 25 degrees Celsius water to grow. Really more about 28 to 29 degrees is where we see really good optimal growth. Energy costs, this can be quite high, especially when you're culturing dense populations of shrimp. Labor costs are a big issue in many countries and many regions. Production, how much shrimp do you want to grow? Do you want to grow shrimp all year round? You know, a lot of places it's a seasonal harvest where you harvest one time per year. That is fine in some cases, but it's a little bit restrictive in others. We're trying to work on systems where we can even harvest on a weekly basis, because to produce fresh seafood, that would be ideal. How big are the animals that you want to culture? That dictates how long you need to grow them. In the US, the consumers really seem to favor large shrimp, just about as large as possible. I know from my work in Brazil that many locations in Brazil, farmers and researchers are growing smaller shrimp because that's what the market demands. So traditionally, to farm shrimp, you would farm them in extensive ponds. It's been for a long time that these are flow-through ponds. Either water's pumped through the ponds or they're influenced by tidal cycles. In very low density situations, you might not have much water exchange, but you have very low stocking densities of shrimp. In your flow-through ponds, extensive ponds, you're usually talking about rather low densities of shrimp, 25 shrimp per square meter. So, you know, places like Ecuador have even stayed down in these low densities, and maybe 50 shrimp per square meter or so. At least the last time I was in Ecuador, that's where they were at. And so, you know, that can be a good strategy still. You know, that can produce some consistent results. However, one of the big problems with flowing water through ponds especially is that disease can come into the pond. Viral diseases have hit the industry very hard over the years. And it seems like every few years there's a new disease or a recurring disease that pops up in regions, and then it'll spread to another region. Early mortality syndrome was one that over the last 5 years or so has hit the industry pretty hard. And the diseases can come from the wild, from wild animals, from other farms in the region, hatcheries. The animals from the hatcheries themselves can be carrying disease if the hatchery's been exposed to something. Other animals and even people can carry diseases into a farm. But the industry's moved towards intensification in most cases. Most of what we see in Thailand has intensified heavily, for instance. And I've seen a lot of intensification in Brazil as well. I was in Rio Grande do Norte in August, and got to visit quite a few farms, also in the state of Sierra. So what that means is that people are starting to line the ponds to limit that water and soil interaction where you can lose a lot of oxygen. They're starting to aerate more, increased aeration because of animal respiration, also the respiration of microbes in the water. You also want to move water around the pond to make sure it's mixed. You want to keep solids, particulates in the water column suspended, because if they settle out on the bottom, You can get sludge deposition, which can produce ammonia and sulfide and things. And so a lot of times ponds are mixed in a circular pattern with a deeper spot in the middle where sludge can be accumulated and then drained. Usually there's a drain. There would be a drain in that middle location. There's other strategies as well. So this increases biosecurity. We've seen that hatcheries have become very paranoid about biosecurity. They've moved towards foot baths and limiting the number of people that can come in. Even car baths where the vehicle driving in has to go through a wash down type of procedure to disinfect. They've reduced water exchange, although most of our hatcheries are still located on the coast, and they still do have quite a bit of water exchange. In most cases, they heavily disinfect that water before they use it. Intensification means that in many cases, people have moved into greenhouses. This is a farm in Rio Grande do Norte, I believe. And as you probably know, because of white spot, viral disease, people have really tried to move indoors into greenhouses where they can keep a higher temperature. That tends to, the shrimp tend to do better with the virus if they have a higher temperature. And so people have built these enormous greenhouse structures where it's really interesting. You have several ribbed regions of the greenhouse that go on and on to cover ponds that are acres, many acres in size in some cases. And again, you can see these are aerated. We've got different types of aeration going on here. And this allows for much better temperature control, excluding disease in many cases, keeping predators out. Birds have always been an issue, for instance. And then if you want to go a little further, you can even look at walled buildings that are actually insulated. In Kentucky, as I'm speaking to you right now, there's snow on the ground. It gets pretty cold here in the winter. November 30th right now as I'm recording this, and we've got a few centimeters of snow on the ground, and my kids were out playing in the snow just this morning. And so we want to grow shrimp in a region like this, and we want to grow them all year round, then moving into an insulated building is usually the best option. And we've seen farmers do this throughout the US, and Europe, and Canada. There's probably a farm or two like this in Brazil, I would assume, although I don't know of one off the top of my head. And this gives you maximum control, really controlling that temperature. You can control the lighting, for instance, provide lighting for people to work safely. And some of our experiments recently have looked at lighting as it might affect the shrimp as well. And we found some interesting results from that. This is where you get the maximum biosecurity. You can really limit the amount of people that come in. You can set up, tanks that are quarantine tanks for your animals to quarantine them for a while to make sure that they're disease-free before they go out into your production systems. You can do that in other types of structures as well, but this is really the maximum level of control. So why would you want to grow shrimp indoors? And I mean greenhouses or walled buildings, either one. Well, you can start to locate the systems in unique places. Like I said, in a landlocked area like Kentucky. This is a warm saltwater animal, and if we're going to grow them, we need to recirculate that salt water because it's expensive usually. And this allows you to tap into new markets that weren't available, in the US. I think of markets like Chicago and St. Louis. These are some of the big cities that are in the interior part of our country. And they're away from the coast. Some people are looking at doing things like reusing old infrastructure. In many cases, and I'll show you a picture of this, agriculture has changed over the years. And so people are using old structures that were used for hogs or tobacco production, things like that, and now growing shrimp in them. If you have consistent conditions, that allows you to predict the results. So you can decide when you want to harvest your animal and how big you want it to be and things like that. You have a lot more control over that. Produce larger shrimp, that gives you a higher price in the US and potentially grow them any time of the year. So how do you grow shrimp indoors? Well, you have to use recirculating systems, as I mentioned, which is defined as less than 1% water exchange per day, but almost always we're much, much lower than that. You have to filter the solids and you have to filter the nitrogen. Those are the two things that you immediately have to do in order optimal for the shrimp to grow in. And there's a variety of ways to do this. You've probably heard of the term biofloc. That's been a very popular topic of research and industry over the last few years. And then there's clear water recirculating systems. Many fish are grown in these, like salmonids come to mind. There's others as well that really require clear water. Well, you can grow shrimp in those too. And then what we've been looking at lately is kind of trying to hybridize these two strategies, biofloc and clear water, and trying to develop systems that can provide the benefits of each of those strategies. So biofloc refers to systems that have a lot of these particulates in them. These are called biofloc particles because they have a lot of biota in them and they flocculate together. And so you allow these particles to accumulate. They come about naturally. Microbes have excretions that they provide and produce, and that makes them sticky, and they tend to stick together over time and form these particles. And this is the biofilter. This is what gets rid of your ammonia for you as long as it's functioning correctly. And there's been a lot of research on the idea that this could be a potential food source for animals like shrimp and tilapia. I'll show you that the shrimp have a unique way of filtering particulates out of the water. The center photograph is an electron micrograph of shrimp appendages, and they have this webbing on their legs that they sweep through the water. And as they do, particulates are attracted to the webbing, are caught in it, and then they wipe that across their feeding apparatus, their mouth. And they can actually eat particulates out of the water in that fashion. Tilapia can filter particulates out of the water. The fish I'm holding in the picture on the right is, we call it a paddlefish. They're native to parts of the US, and there's a species in China and Russia, I believe, as well. Anyway, they can filter particulates out of the water. That's their primary way of eating in nature. And so there's plenty of species like that. There's all kinds of fish in Brazil that can filter particulates out of the water. And so they might be potential candidates for something like a biofloc system. If they can get some nutrition from those particles, then they are recycling the nutrients that are contained in those particles, which could lower the feed costs. We've seen some evidence of that over the years. There's also evidence that the microbes provide things like digestive enzymes and the like, which can help the animals have better feed conversion rates as well. But biofloc systems are biologically more complicated. Another point to make is that they're not all the same. If you change some of the management or the temperature or the environmental parameters that are going into the system that are affecting it, then you can really change the way that the system functions pretty dramatically. And so when we talk about biofloc systems, one person's biofloc is not the same as another person's biofloc necessarily, which has created some confusion in the industry, because some people have had a lot of success with this strategy and others haven't. Many farmers that are just starting out, especially if they don't have a lot of aquaculture experience, seem to have a little trouble with this concept because it is biologically rather complicated. You have to understand a little bit about how the microorganisms are functioning and what your water quality parameters mean and how to make changes to the system. On the graph on the bottom, you can see also that the shrimp oxygen demand increases over time as shrimp grow, and the microbial oxygen demand stays, generally roughly the same. The system's developing for a little while, but then over time it stays roughly the same. There's times when the microbial oxygen demand is even higher than the shrimp oxygen demand. That can be very substantial. That's one of the drawbacks of a biofloc system. You have to aerate that water pretty intensely to make sure that the microbes have enough oxygen as well as the shrimp. And then the opposite side of the spectrum on recirculating systems is clear water recirculating aquaculture systems, RAS. Here you have very heavy filtration. We can have solids filtration, of course, biological filtration, which you need in any case. But then people go to lengths such as adding ozone to the water to really disinfect it and oxidize organic material. There could be a little bit of water exchange, a little bit more water exchange potentially to really keep the water crystal clear. Ultraviolet light can be provided in the filtration loop. And some really high-tech filters can be used to really get everything out of the water. If you actually want crystal clear water, like what you see in the top picture. But this is a farm I was at in Germany last year, and you can see the density of the shrimp in here. That's the real amazing thing. There's some horizontal substrate that the shrimp can crawl on and get away from each other with. And we're talking densities of potentially 20 kilos per cubic meter, maybe even more, 25 kilos per cubic meter of shrimp. And that's a lot of biomass for shrimp. In the shrimp world, biomass isn't as high as it is with fish aquaculture. And anyway, there's some theories about that, but that's getting way up there for shrimp. And that's potentially the trade-off with having all that extra filtration. And obviously you're going to have to pump water. You can see this is the part of the filtration system that accommodated that picture on the top, and you can see lots of pumps moving lots of water through the system. It's I don't know, maybe there is a way where you can justify that level of filtration and technology if you can really push that biomass very high. And part of the reason you can do that, I believe, is that you have very low bacterial levels in the water, very low chance of infection. You can probably manage the system a little bit more effectively because you can see the shrimp, and if there is an issue, you can potentially address that a little bit quicker than you could in another more turbid system. And then we have what I'd like to call hybrid systems, which is what we've been working on at Kentucky State University now for a little while. We've kind of come to this conclusion that, well, clear water systems have a lot of benefits, and biofloc systems do too. What if we combine some of the benefits of each? And so basically what we do is just add a biofilter, an external biofilter to the system. And that provides a lot more consistent water quality. The farmers we've worked with to use these have had a lot more success with that because it provides a more consistent environment where they don't have to make rapid management decisions to save the shrimp as they would in a biofloc system potentially. Here's some examples of insulated buildings that we've developed. This is a old pole barn, basically, just poles and sheet metal poles with sheet metal on it. And we came in and spray foam insulated it and put down some gravel on the floor. And that creates a really nice environment here in Kentucky to grow shrimp year round. And this is a research facility, but we've seen this done in commercial facilities as well. This is an old tobacco barn. Tobacco was a big crop in Kentucky years ago, and it's really died off for the most part. There are a few farmers raising tobacco, but not nearly as much. And so these barns were big and drafty because they would hang the tobacco leaves up in them and let them dry out. And they have big beams inside. You can see the wooden beams. And what this farmer did is came in and put up some paneling and some spray foam insulation. And then in the bottom picture, you can see that he put swimming pools in. Swimming pools, turns out, make a very inexpensive tank. It's about the cheapest way to get an above ground tank that I know of. And they last for several years at least. We've seen them in operation for at least 3 years. I think they're going to last quite a bit more if there's a little bit of maintenance with some of the metal parts on them. And so it makes a nice indoor year-round shrimp production facility in this old tobacco barn. These are some greenhouses where we have, these are on the KSU campus. And these are just metal poles with plastic over them. We call them high tunnel greenhouses. They're very simple, no external heat, very little heat management strategy, although the sides roll up and we can throw shade cloths over them and things like that. It gets warm here in the summertime and cool in the winter. So these are seasonal. We operate these about June through September is when our seasons are reversed, of course, from the southern hemisphere. And that's about the length of time that we can get warm enough temperatures for good shrimp growth, although we can keep them in there potentially a little longer than that. They just may not grow as well. And these are operated as biofloc systems, so we just aerate the water, and we have settling chambers to take out the solids, which I'll describe. These are partially operated through solar power. We have half of each greenhouse has biofloc shrimp tanks in it, and half has row crops, organic row crops. And so these are integrated agriculture systems. And the photovoltaic arrays at full production on a sunny day offset our costs of blown air, and then anything extra is sent back to the grid. So they're grid tied systems. So you have to control solids and you have to control ammonia. Settling chambers are very effective ways at controlling solids. We recommend these for farmers. Very simple. We flow water into the chamber, and it has a large baffle where the water slows, and then the solids settle out on the bottom. We can drain those with a valve, and then the clear water near the top returns to the tank. And we've really become very big fans of foam fractionators. The settling chambers tend to take out the large solids, and foam fractionators they do a really good job at taking out small solids. You create a column of air inside a chamber, inside a column of water. Air bubbles are slightly charged, and they attract the slightly charged small particulates to them. Proteins, for instance, these are often called protein skimmers. Other charged organic particulates, bacteria, algae. If you get a lot of foam in your system, this is a good way to strip that foam out and take out whatever is causing that foam. This is one that's created with an air diffuser, but we have some also where we put the water and air in to the chamber with a Venturi style nozzle, which sucks air in and creates very small bubbles. And then the bubbles foam up at the top and they're discharged through the top. And there's a lot of different ways to make these and different strategies and adjustments that you can make to make them function better. But they really do a good job taking out the smaller particulates. And if you do get a bacteria bloom, it's a good way to take care of that and get a lot of the bacteria out pretty quickly. So that's solids. And then we have biofiltration, which is how we deal with ammonia. Ammonia is very toxic. Nitrite is also toxic, not quite as bad. Nitrification converts ammonia over to nitrite and then on to nitrate if it's functioning correctly. And as you can see in this graph, though, it can take a little while to develop that bacterial community. This is in a biofloc system where you don't have any substrate for the bacteria. These bacteria need substrate to live on. And so our hybrid type system, we provide biomedia, which you can see on the picture on the right, which is substrate for the bacteria to live in. And so again, that provides a much more consistent environment for these bacteria to live and work for us. And it's really produced much more consistent results. It is an added cost. And in very large aquaculture systems, of course, you're going to need a larger biofilter, which can add up. It could be a way just to get the system started as well. And then kind of detach it once your biofloc system becomes established. That's potentially a solution to that. But on these smaller scale systems, these are about 4,000 gallons. I'm sorry, I don't have the metric conversion of that right off the top of my head. Maybe about 13 cubic meters. You might want to check that though. And these 50-gallon drums, which are very commonly available in our area, provide great, very simple filters. First, the water goes into the settling chamber, and then it goes over into the biofilter. Water goes in through the top of the biofilter and out through the bottom, so you have maximum contact on that biomedia. And of course, you want to keep it aerated to make sure that your bacteria have oxygen and that the media is mixed. In these simple indoor systems, farmers have started using home water heaters, such as the one on the left, and water is pumped through plastic tubing. And that plastic tubing is called PEX. It's used in plumbing and households quite a bit, and commercial facilities. And you pump the water through a coil of that that's inside the tank, and that will distribute heat into the tank, pumping hot water through that PEX tubing. And you normally have a valve there to control the flow rate if you want more or less water, depending on the temperature you're trying to maintain in that tank. It's very effective. And then the water just simply returns back to the water heater. You've got it on a return loop there, and a pump that constantly moves water through your shrimp farm. So I mentioned that we try to convert ammonia over to nitrate. Well, at some point, nitrate does become toxic. Shrimp start to slow down and stop growing. I like to take care of it about 250 milligrams per liter nitrate nitrogen. About 300, and you really start seeing problems. One of the things we've done with our research recently is looking at plants to help with this. And of course, we need salt-tolerant plants. And we found quite a few. Of course, there's coastal plants that are not edible. Those can be very effective, actually. But we've looked at some edible plants as well. Swiss chard is one that does pretty well in salt water. It's popular here in the U.S. in supermarkets, but it has a very strange flavor when it gets real salty. Scurvy grass is native to the United Kingdom. It's in the top picture here on your slide, and Salicornia is another one. One of the more interesting results from our research lately, though, is that kale has done really well in aquaponics. You can see even at higher salinities, the kale grows. It doesn't get quite as big as it does in fresh water, but it does grow, and it has a flavor, a salty flavor when it's grown in salt water, but it tastes very good to me. Kind of a sweet and salty flavor, at about 10 parts per thousand to 15 parts per thousand. It has about as much salt as I would personally normally add to kale if I were to cook it. The bottom plant is called sea purslane. It's an interesting plant native to coastal areas in the United States. It's crunchy and kind of salty and unique. So those could help us with nitrate removal. We've also got some experiments looking at denitrification chambers, making containers that contain biomedia and trying to let them go anaerobic so they can facilitate the process of denitrification, which removes nitrate. But you have to be careful with that. It can produce sulfide because you're in an anaerobic environment, and it can even produce ammonia again. So research is ongoing with that. Another way that we're looking at conserving water is using inexpensive salt. Well, actually, we're looking at this because if you had a more inexpensive salt mixture, you could discharge more water if you need to, because the salt mix that we normally use is called, well, the brand name is Crystal C. I'm not trying to endorse anybody, but it's a complete salt mixture. And so we add it to the tanks, and it does really well. The shrimp do well with it. But it's expensive. It has a cost. And now we've got this formulation that you can see on the left side of your screen, which is from some previous publications, actually. We're working to try to modify it just a little bit. Probably need a little more calcium in some cases, but we're still looking at that. Anyway, in our intensive recirculating systems, we looked at using different levels of the Crystal C versus the least cost salt mixture, and we ran an experiment on that, and we found that there was no significant differences at all in shrimp production among the treatments. We ran another follow-up experiment that again showed no significant differences because we were worried a little bit about the 100% least cost salt. It wasn't significant because of some variance issues, but it did have a lower survival. When we reran experiment with much higher levels of least cost salt and even 100%. Again, we found no significant differences. So I'm pretty well convinced that this is a pretty good salt mixture to use. Now, over time, you're going to have minerals that are taken out of the system and some things that accumulate potentially. More worried about things that are taken out though over time. Calcium is one, potentially potassium, magnesium. These are things that you probably want to check about every time that you grow shrimp in the water, and you may need to add some to it or adjust the levels. Basically, you want salt water that has about the same ratios as seawater. So my time's up. I could talk all day, but I won't. I hope you found this to be helpful. Obrigado. I appreciate your time. Congratulations on 50 years for the program. That's an amazing accomplishment. Here's some.
All right. So I have a couple questions here. Thanks so much for Dr. Ray joining us for that Q&A. I don't yet see him on here, but I assume he'll be on here in just a second. I assume that Julia will inform me if I'm missing him there. So again, there's a little bit more on the research side added over to it. Oh, Dr. Ray's coming in right now. Obviously hits on a little bit of research from a couple different projects that they've got going on, including not just their biofloc systems and their RAS systems or their hybrid systems, but incorporating that least cost salt solution there is very important. So Dr. Ray, you're muted, but thank you so much for joining us. We do not have any questions right this minute regarding your presentation. So what we're going to do is switch immediately over into just the open panel Q&A. So I would ask that Craig and Tracy, Andrew, you already have your presentation open or your video on, and Curtis, go ahead and turn on your camera. And I've got a couple questions up here, but folks, please think about what you saw today and ask us any questions that you would like to know. And again, for those of you who didn't see, the president of the OAA, Bill Lynch, posted down into the chat as well. So make sure you check that information out. Okay, so first question, just really quickly, someone just asked if I have contact hours available. Of course, I work for Ohio State University as part of the land grant system, as well as I'm doing some regional work here in the North Central Regional Aquaculture Center. I don't believe my email address was posted anywhere. Julia will post that in the chat, but I do open Zoom office hours, usually every Friday, but just message me. We can set something up, either talk on the phone, you can send me pictures, or we can Zoom just like this. After COVID, we can certainly meet up in person, but for right now, OSU is not allowing me to travel until the end of June. All right, this question is for Curtis. And again, this 11:40, if we run a little past 12, not a big deal. Curtis, would you still put windows in your building if you were building it after raising fish?
Yes, good question. I put the windows in by personal, just for me, myself. I like the natural light. I'm in there working a lot. Definitely in the summer times, I have those windows open, circulating a lot of air, getting a lot of that humidity out anyhow. I don't think the fish mind. I mean, I don't think they care one way or the other about the light. They can live, I think, in darkness, so they don't have to have light per se. But yeah, I'm probably losing a little bit of energy through those windows with heat in the building. But I think I'd rather have the light in there, natural light, just to work in there. Good question.
Thanks, Curtis. So this next question is for, it says the Bells and Curtis, but I'm going to also ask Andrew the same question as well. We'll start with Curtis. What percentage of your total system volume are you replacing each day with makeup water?
Depends on how much I'm feeding. So if I'm feeding a lot and putting a lot to it, I probably need to be exchanging some water. I don't go off a percentage really. I kind of have it down to a timer. I set a timer on my phone, and it goes through. So usually I might be at, some days I don't exchange any water. Other days I might exchange 2-3% maybe, if that.
Thanks, Curtis. Craig and Tracy, what about yourself over there?
You know, we're feeding a lot of feed right now, and so we're at 3 to 5% a day, pretty consistently.
So Andrew, you mentioned less than 1% on some of your RAS stuff, but with the addition of this biofloc, kind of this hybrid system, obviously there's a reason you got that biofloc. Are you still less than 1%, or what are you guys doing on the saltwater side over there?
Well, for saltwater, first of all, there's evaporation. You got to replace evaporated water, which is, we don't lose any salt that way. In the greenhouses, we get a lot of evaporation, especially in the summertime. Indoors, it's a little bit less. So that just varies, and you always have to deal with that. But then the makeup water that we lose is from our filters, mostly our solids filters. It's very hard to remove solids without removing some water. And so we are somewhere in the neighborhood of 5 to 8% for an entire crop of shrimp from the time that they're, basically from the time they're hatched up to harvest.
So about 3 months.
Salt water, that salt water we have to replace, which is important because salt water is it's a little more of an expense at an inland facility.
And Andrew, that's a production cycle of about 3 months?
It's about 5 months. Actually, yeah. When we get the post larvae, they're about a month old from the hatchery, and they're tiny little things. And then we'll do a nursery phase typically, which is about a month, and then a grow out phase, which is about 3 months.
Okay, great. So Andrew, another question for you. Someone wants to know about plans if you could do a very small 100-gallon indoor shrimp production system.
Sure, you can grow shrimp in an aquarium. We do feed trials and things in small, 20-gallon aquariums, 100 gallons. They'll grow fine. You're not going to get a commercially meaningful amount of shrimp out of that. Probably somewhere in the neighborhood of 5 or 6 pounds of shrimp, maybe. But it can be done. Yeah, shrimp are pretty adaptable to various size containers.
Thanks, Andrew. All right, now I got a question for Curtis. All right, Curtis, is there anything that you would do different as far as the construction of your building?
Oh, no, yeah. Hindsight's always better than 2020, as the saying goes. But mainly probably more foam on the walls, just to cover up the wood. We didn't cover up the wood structure as much, and so we do get a little bit of condensation on a little bit of that wood that's there. And so now the tanks are in place, it's kind of tough to come back and foam that. But that might have to happen in the future, just to kind of give that vapor barrier. The ceiling insulation, we only put 2 inches in the ceiling, but the intent is to go back over and just do some blown-in insulation, which is a little cheaper, because you're going to lose most of your heat to the ceiling. But the building, maybe I should have went a little wider, I guess. I did 52 wide. I probably should have did 54, maybe, give me 2 more feet or so. The intent is we can drive vehicles right down the middle of the facility. And so right now I only got about a 9-foot in between those tanks for my driveway through the facility, which would be nicer to be a little wider. Other than that, no, I'm happy with it so far.
Thanks, Curtis. And what you said right there reminded me, just a shout out to the North Central Regional Aquaculture Center. One of the projects that they funded, it was a small grant, but they, a project out of Purdue, looked at trying to assess from kind of the HVAC sides of things. And I believe they stepped over to Craig and Tracy's facility as well, maybe to take some measurements to try to do a little write-up for their project. So I don't recall really what the results were or where all they went, but I know they hit a couple locations, and that publication is on NCRAC's website. That's ncrac.org. Answer live. All right. So this question is for Andrew. What about filtering the shrimp water through a seaweed tumbler?
Yeah, there's some research out there on this topic. I have not worked with seaweed macroalgae myself. Yeah, I would worry about trying to keep it clean, I guess, keep it from becoming dislodged and entering the rest of the system, I suppose. But yeah, it's a possibility, sure. The logistics of it, I'm not sure.
Thanks, Andrew. All right, another question for Andrew. I was wondering if the survival of the shrimp you showed in the last study of your talk is commonly seen in RAS or your system. And that I'll just, because you probably don't have it in front of you, I'm not going to give the standard deviation, but you're looking at about between 57% and 70%, 73% for that salt solutions you were talking about.
Right. Yeah, I would say that's a pretty common range commercially. Yes.
And that would be from the time they hit the production system, not from the time that you have your, not from the time you get the PLs in, because you grow them up a little bit, right?
Right. Right. We're probably, well, yeah, that 57% is a little on the low side, but we're probably in the neighborhood of 60 to 70% overall for both the nursery and the production cycles.
Thanks. And to say, it actually doesn't say if it's standard error or standard deviation, but it's the 100% least cost solution. So that's the new stuff that you're working with. And that's 57% plus or minus 6%. So you could be as high as 63 is what you saw in probably at least one of those studies. Or replica.
Right. And we just completed another study looking at that salt mixture where we used smaller ratios of the crystal C. We went, anyway, we redid the experiment with some smaller ratios, and we found that 100% least cost salt mixture did much better in this follow-up experiment in terms of survival, that is.
Great. Thanks a lot, Andrew. And for those of you who don't know, Dr. Ray and Kentucky State University, the aquaculture program, put on a very great saltwater shrimp workshop in 2018. I think it might have been the fall of 2018. And all of those presentations were recorded. There's shrimp producers from large scale producers from all over the world that presented there. That information was recorded. They're also talking about pathogens. They're talking about shrimp nutrition. So there's a lot of great presentations on that YouTube channel that I shared with you as well. Andrew, hopefully you guys will, a grad student or something, I know you guys have presented at Aquaculture America, but hopefully the same, this least cost stuff, if it's significantly cheaper, we'd certainly love to see a YouTube video on that up there as well.
Yeah, we need to do that. Yeah, we've got a study. It goes into the next question, I think. Is the next question about the cost?
No, I've got quite a few questions here. Oh yeah, sorry. So we do have, what are the production costs and what are shrimp selling for out of Midwestern shrimp farms?
Yeah, so this ties into both the previous question and this one. That there's a graduate student at Purdue that just completed his master's thesis on this topic, created an economic model of the indoor shrimp production systems. And in that, he considered the cost of the salt. It was part of the same grant that funded that research. And so if somebody wants to email me later, I can email you a copy of his thesis. We're working on getting that published as well. It was a substantial cost. I don't remember the exact percentage, but you know, it was maybe somewhere in the neighborhood of 7 to 10% of overall cost could be saved by using a less expensive salt formula. And so the cost of production, that student's economic model was a little on the, he had some pretty high numbers. He had estimated a very low survival rate based on some results out of some Midwestern shrimp farms. off the top of my head, I'd say production, it's variable. Some people are better at, they just get better production than others. It depends on your experience level largely, and the ability to keep the water quality stable and things like that. But I'd say production costs are somewhere between $7 and $10 a pound. And our farmers here in Kentucky that I work with, they really target at least $15 a pound sale price. And sometimes they can get a little more than that. And so, yeah, these are niche markets. This is a niche type of product. They go to farmers markets largely and try to get direct sales to consumers, that type of thing. People who value the fresh, local, sustainably grown type of product.
Thanks, Andrew. And as far as I know, here in Ohio, I believe we're up to 4 saltwater shrimp production facilities, all indoor, of course. That's what I know of here in the state of Ohio. Of course, there are others in Indiana and throughout the Midwest and the rest of the country as well. All right, now we're gonna, it's a question about drum filter. So we're gonna let Curtis handle that since Craig's not really using those drum filters too much. But so it says, how do you handle waste coming from the drum filter? What level of cleaning is required before it can go to the river?
So my waste, that drum filter automatically removes waste. So it automatically does its backwash as needed. And the backwash on the drum filters depends on how much you're feeding. It can happen every 5 minutes or so that thing goes, every 5 to 10 minutes really. And it just goes outside the building. There's a in-ground, basically settling pond, maybe a 30-foot diameter settling pond outside that settles out some of the waste, and the rest of it just runs down over the hill. And so that's kind of what happens today.
Thanks, Curtis. And regarding kind of what, quote unquote, what level of cleaning is required before it can go to the river, there are EPA standards as far as what you're allowed to discharge, how much you're allowed to discharge, and things of that nature, and whether or not you need remediation before water is discharged from your facility. I will say that, to my knowledge, everyone here in Ohio is small enough in scale that they do not need a discharge permit. The only discharge permit that I know of is actually held by, it's called an NPDES permit, which stands for the National Pollutant and Discharge Elimination Service. And that is the only one that I know of is actually held by the Ohio Division of Wildlife, because most producers are small enough that doesn't matter. There are differences based on whether or not you're growing and culturing a warm water animal or a cool water animal, as well as how many poundage your system is growing, as well as how much you're feeding and discharging, how often is water discharged from the system. So you might have a pond facility that just about never discharges, but they feed every single day and they're producing quite a lot of product. But because they're not really discharging but once or twice, if that, a year into their rivers, they're well below any of those numbers. But there are EPA levels that you have to abide by. All right, this one's for Ripple Rock. So Craig and Tracy, what do you use to remove solids?
We use a bead filter. It's a filter from Aquaculture Systems Technologies. A number of those bead filters, and so on a daily basis, those filters capture the solids, and once a day those filters are plugged in, spun, backwashed, and the solids then that they capture over a day's time are sent to a settling pond outside, and water then flows over the hill and down to the river, right, is what the previous question stated. So
thanks, Craig. All right, this one's for Dr. Ray. They want to know, where do you get your, they say larvae, your post larvae are also known as PLs. Where do you get your PLs from? It says, where do you get the larvae from? A hatchery on the coast, ?
Yeah, so shrimp are arthropods, kind of like insects. They metamorphose. They have a metamorphosis period where they're actually larvae, and they go through some stages where they don't even look like shrimp. But then once they're fully formed and look just like the shrimp that you would eat on your plate, except that they're small, we call them post larvae. And so we get those post larvae. At that point, they're pretty hardy, and they're able to ship really well. So you can actually put about, normally the standard is to put about 15,000 of those in a bag that's, I don't know, about 2 feet wide, filled with a little bit of water, some activated charcoal, and some oxygen. And you can ship those across the world, basically. They'll last in that bag for about 36 hours. And yeah, the hatcheries we use are, lately we've used 2 that are both located in southern Florida. American Mariculture we had been using, and now we're using a new hatchery called Homegrown Shrimp in Florida. And they are both on the coast, yes. Which is one of the vulnerabilities of the industry, I might say. Sorry, I know we're running a little late, but
Oh, you're fine.
a couple of years ago, there was a hurricane that hit Florida, and then it hit Texas, where there was another hatchery. And so there was a substantial disruption in the supply of post larvae for the industry. And a lot of people in the US get shrimp from these hatcheries, of course, but also in Canada and Europe, they mostly get their shrimp from US hatcheries. So that's been one of the limitations of developing the industry, is that there's been very few hatcheries historically, and they do have some vulnerabilities.
Thanks for bringing that up. All right, next question is for anyone really. Do you know where to buy tilapia as mixed sex?
I think Americulture can sell a mixed sex. They typically don't to their producers, but I think you could get some from them. I think there was a guy at one of the conferences here in Ohio a while back that they were doing some things here in Ohio that probably, if you just need a few, there's a lot of homegrown hobbyists that are growing them. So
Yeah, I think I know the person you're talking about, and if I'm not mistaken, if it is that person, they also have thousands of acres of row crops on the side as well. So I think that aquaculture might have went by the wayside for a little bit while they took care of the farm there. But yeah, I agree. Depends on what level you're looking for. I'm sure we can find them some. You can email me outside of this. Julie put that down in the bottom, and we can work to find you some mixed sex if you need. All right, this one is about salinity. So Andrew, do you try the low salinity, such as 5 ppt, to raise shrimp NARAS? And Andrew, maybe just let folks know what standard full strength salinity is.
So average ocean seawater is 35 parts per thousand. Sometimes that's grams per liter is the same unit. And so we normally when we get the shrimp from the hatchery, they're actually at about that full strength seawater because they're coming from a coastal hatchery. And so we'll start the nurseries off at about full strength seawater, but we keep the water level in the nursery very low, and then gradually add fresh water over the course of several weeks and bring them down to, our standard is 20 parts per thousand to grow the shrimp throughout the culture period. But lately we've moved towards a little bit lower at 15 parts per thousand. I've grown shrimp as low as 10, and they've done pretty well actually. And they will grow at 5 parts per thousand. The risky thing that you get into is that things like ammonia and nitrite are more toxic at lower salinities. And so in these intensive systems, we can get little spikes of ammonia and nitrite from time to time, and that'll be more problematic at the lower salinity. But shrimp can tolerate that lower salinity. They naturally live in estuarine systems where the salinity fluctuates quite a bit, so they're adaptable to that, but there's a little bit of risk involved.
Thanks, Andrew. That's a lot for our finfish as well. As long as we give ample time for the animals to acclimate, they do a lot of well, and they do quite well in a variety of different situations. You just have to really take the time to acclimate them. All right, next question will be for Curtis and Craig and Tracy. They want to know, how do you sell your tilapia? Is it just live? Are you doing any processing or anything like that?
Oh, I'll answer first. Mine, yes, they're going live. They also go on ice. Mainly past month or so has been going on ice to another fish farmer that has his processing license. And he fillets them up and takes them to local farmers markets in Columbus. And then also live to pond stocking as well. I've had customers come to the facility and fix them up and takes them to the pond, or we deliver them to ponds.
Craig and Tracy, what about you guys?
We're selling ours live into grocery stores, so we're delivering them to grocery stores on a weekly basis in Columbus. Occasionally, we'll take a run up to Cleveland, but generally we're in Columbus on a weekly basis to some international type supermarkets.
Thanks a lot. So that's it for the Q&A on my side. I will say I already marked answered on one question. I don't know that I'll find it backing up what someone asked about essentially aquaponics. If this wasn't the algae, the seaweed tumbler question, this was another question. When Dr. Ray's presentation was going, they were asking about biofloc with plants or any other sort of macroalgae. So I will give Andrew a chance if he wants to say anything else about biofloc or saltwater shrimp aquaponics operations, and what you guys' experience has been outside of the presentation that was given.
Yeah, that was a new line of research for us in 2019. We've continued that on. Kale has been really exciting, like I mentioned in the presentation. Some of my next questions are, well, will people eat these plants that we've grown in saltwater aquaponics? They tend to taste a little different. We grew Swiss chard, for instance, and it had a very unusual and I don't think a very good flavor. But the kale just tastes like it's been salted. And so how do you market that? How do you sell that? It's different. It's not your normal kale that you would find. So that's kind of the next questions that we're looking at, is marketing and consumer preference studies, hopefully, and maybe do some flavor profile analysis type thing to find out if farmers could actually grow this and sell it. And then also the other thing is, how much nitrate do these plants take up? And if they're taking salts out of the water too, we're gonna have to replace those in the water. Calcium and magnesium tend to go first, and those are really important for shrimp culture. So those are some of the questions that we have coming up. We're going to try to answer.
Thanks a lot. I appreciate that. And I might have jumped the gun because I was trying to make sure on the questions that I hit everybody. But someone did mention, we just talked about tilapia being sold live, head-on gutted, processed, whatever it may be. Please do note that if you do have a fish farm and you want to do any sort of processing, I don't care if it's shrimp and you want to pull the head off, or if you want to do a full fillet of a tilapia or any other product, there are lots of rules and regulations that go along with that, including working through the FDA to make sure that your processing plant is up and approved and you've gone through the training. The specific training that you would be looking for in order to make sure that everything is up to code would be seafood HACCP, and HACCP is HACCP. That's hazard analysis of your critical control points. But you can message me on that. But that's all about food safety and make sure that folks are getting safe, high quality animals, or products. Okay, everyone, that's it for the Q&A there. We're only 5 minutes over, so we've actually done very good. I want to thank everybody for their time and effort here. I appreciate it. Please contact myself outside of here. Again, Julie put my email address in the chat. I'm not very hard to get a hold of. Again, thanks to the OAA And again, for the OAA, they do have a membership drive running towards the through the end of the month, where you get 2 years for basically a year and a half, or yeah, I think 2 years of time on as a member. I'm sorry, for a lesser price. They also throw your name in the hat for, if you join before the 28th, you get a chance to, you know, get a free conference registration, a free t-shirt, things like that, to try to encourage you to join. And I guess the last thing I'll say is we do have a new avenue coming up that we're still toying with on the board sides of things, but any use the service Discord, we're trying to really add a extra way for producers to talk to other producers. And so we're actually going to release Discord for members only, and that'll be an OAA thing. So keep an eye out for emails from Jenny and Bill, President and Vice President. More on that as we're coming up soon. So with that, thank you very much to the presenters, and thanks so much for the those who attended. Thank you guys very much for taking the time out, and hope you have a great rest of your weekend.